In association football, a team's formation generally depicts how players position themselves on the pitch. This typically comprises 3 or 4 numbers indicating those of defenders, midfielders, and forwards laterally positioned across the pitch. A 4-4-2 formation, for instance, entails 4 defenders, 4 midfielders, and 2 forwards, while a 4-2-3-1 indicates that midfielders are split into defensive and attacking roles. Accordingly, formations play a critical role in competitive football. Coaches give it heavy consideration prior to a match, players use it to understand their individual roles in the broader team effort. It is also one of the first things that opposition analysts aim to identify in their assessment of a team. The present study experimentally examines players' tactical behaviors by analyzing their position data under the effects of 2 defending formations. Methods. The study used a convenient sample, consisting of 69 male under-17 footballers from 3 local football clubs. Procedures. As there were 3 clubs, each club performed the experiment on a different day. Before each session started, the head coach of the club divided the players into 2 teams of equal ability, based on technical, tactical, and physical factors, and also taking into account their playing positions. The experiment was conducted on an official-sized natural turf pitch and adopted a counterbalanced crossover design for 2 conditions, for 4-2 defending and 5-3-2 defending. For each condition, each team performed 6 trials of repeated measures, while the other team concurrently performed the role of the attacker, resulting in a total of 72 trials. In all conditions, the attacking team used a 4-2-3-1 formation. As task constraints, players began every trial at the same pitch positions, but were free to move in adaptation to the match situations once the trial began. Each trial began with a goal kick taken by the goalkeeper of the attacking team, and ended when one of 3 events occurred: a goal was scored, the defending team won possession of the ball, or a stoppage in play occurred, for example, from offsides, fouls by defending team, or ball goes out of play. An example of how one session was organized can be found in the table. Players' position data were collected using the local positioning system, Kinexon. The X and Y coordinates of players and ball were then collected at a frequency of 25 Hz. Additionally, a standard HD video camera was placed along the halfway line from an elevated position, to film the sessions for subsequent qualitative analysis. The Table 2 explains in further detail how these variables were calculated, while the Figure 2 provides an illustration. As complementary analysis, players' passing networks were notated to gain an overview of the passing dynamics when playing against each defending formation. At a micro level, individual level, each player's betweenness, weighted in degree, and weighted out degree centrality scores were calculated, while at a macro level, team level, total links, network density, and network diameter were calculated for the network. The table explains their methods of calculation. Additionally, the following outcomes were also recorded. Results. Out of all 72 trials, 66 trials, 92%, resulted in the attack being disrupted. In the 4-4-2 trials, one trial resulted in an attempt on target, while another trial resulted in an attempt that hit the post. In the 5-3-2 trials, one trial resulted in a goal, one trial resulted in an attempt on target, and 2 trials resulted in attempts off target. As a check on internal validity, players' movements were plotted with respect to their team centroid, and qualitatively assessed to ensure that the relevant formations were achieved. Table. For significant differences were found in the following variables: mean dyadic distance, defending team, team width, attacking team, midfield forward distance, defending team, and defense forward distance, defending team. In particular, the 5-3-2 defending formation was differentiated by reduced dispersion, mean dyadic distance, in the defending team, small effect, closer interline distances between midfielders and forwards, small effect, and defenders and forwards, small effect, and reduced team width for the attacking team, small effect. The latter finding was further explored and found to be substantially contributed by the positioning of fullbacks. At the dyadic level, no significant differences were found for distance to nearest opponent, but changes in the closest marking player were found. For some players of the attacking team, left back, right back, central midfielder, attacking midfielder, and forward, no significant differences were found for the other main results. In the complementary analyses, a total of 303 passes were performed in the 4-4-2 condition and 260 passes in the 5-3-2 condition. 33 penetrative passes were made in the 4-4-2 condition, 27 in the 5-3-2 condition. The number of scorebox possessions were equal for both conditions. The passing network analysis, at macro level, showed more total links and higher network density when attacking against a 4-4-2 defense compared to a 5-3-2 defense. Network diameter was the same when attacking against either formation. At micro level, betweenness centrality scores had less variability when attacking against a 4-4-2 defense compared to a 5-3-2 defense, which also showed a high centralization score in the right back position. Fewer back passes were made to the goalkeeper when attacking against a 5-3-2 defense compared to a 4-4-2 defense. Also, more passes were made to the fullbacks when attacking against a 5-3-2 defense compared to a 4-4-2 defense. Micro-level results of betweenness, in-degree, and out-degree centrality can be found in Tiki table, and passing network diagrams are presented in Tiki figure.